Today we are going to learn the basic commands that how to write the, you can say how to create the tables, how to retrieve data from the tables which we store, and the backend we know everything is written in the form of files, right? So, but on the top you feel that you are working in a database management system, but behind the scene, all this you can see all the tables that you create, they are being converted into the file system because HDF, your Hadoop is a in Hadoop, the storage mechanism is through the HDFS, which is basically Hadoop distributed file system. So everything will be converted into the files at the back end, but at the top level, at the abstract level, when you are working, you feel that you are writing, you can say you are working with any kind of SQL package, more or less, not altogether same. But yes, you have certain commands. You don't write, you can say the queries like you used to write in the SQL, but you are given certain commands, with the help of which you can create the tables and you can add data to these things. And we know this Hbase, it is a column family database. So accordingly, we will be creating the tables in the, so we will be creating the column families, and then within the column families, we will be creating the columns, and then we will be adding the values to all those columns. So let us move to Cloudera and we see how we start with the HBase shell, and then we will be writing the commands and see the various commands which are available in order to interact with the, you can say, HBase storage. Here is one document that I've prepared for your practice, that you can practice the various commands which are there in the HBase. And along with that, I have also pasted the, you can say, the output on the screen, that when you write, what is the kind of output you will be getting. Is it visible? This Word file is visible?
Yes, ma'am.
Okay. So let us move to the Cloudera terminal. Here it is. Okay, let's open it again. Close this terminal. So in order to start a work, you see, when we had to start working with a pig or hive, we simply used to write pig and we used to switch over to the pig shell or the hive shell. But for HBase, you have to specifically write HBase, and then you have to write H shell also, because HBase always requires a particular, you can say, the parameter or the attribute in order to start the execution. So we have to write HBase shell, only then we will be moving, switching over from the Cloudera terminal to the HBase shell. Right. So now you can see on the screen that we are now in the HBase shell. So let us now practice the few basic commands which are there in order to get the basic information. So let's start with the status. So these are basically the general commands which are used in order to know what is the status. Status helps in understanding the number of servers which are there in the Cloudera, and like how many are active, how many are dead. So all such information is provided with the status. Then version helps us in providing the information that what is the version in which we are working. Then table help helps us, it provides all the help with respect to like how to create the tables, what are the parameters that we have to pass on, and all the, you can say, all the modifications or manipulations that can be done with the table. If you want to know about that, here itself you can use this particular command, that is table underscore help. Then who am I? It gives you, it tells you who is the current user in the Cloudera server. So let's start with the status. So here you can say it is showing one active server, zero backup servers, one server, zero dead, right? And what is the average load? Because we are not doing anything. So basically, when you will be working on a big project, that times it will help us, in the cluster, we are working on a single node. So if you have multiple nodes in the cluster, then this information will be changing. So by default, the status parameter, it is basically providing us the summary. So whether you write status or you write summary, status, summary attribute, it will give you the same information. So along with that, if you want to know more details, beside these details, if you want to know the more details about your server, so you will be writing one of the parameters that you can use as simple. So here you see. So now the details. So what is the same information? One is which one is the active server? It is giving the name of the active server. There are zero backup masters. So I told you it is based on the master slave architecture. We have one is the master node, and what others are the slave nodes. And these slave nodes are basically the region servers, right? So in order to see this master node is responsible for maintaining all the meta information. So there is, you can say we need to have a backup of the master also. Like for the data, for the metadata, we maintain a copy of the master so that if the node which is acting as a master, if it fails, we have a backup for that. Similar to the concept of replication, which is being applied for maintaining a backup of the data itself. So here you can see it is providing the number of requests per second, number of online regions, user heap, maximum heap, number of stores, number of store files, store of uncompressed, then store file size, mem store. So all the information that you need to know. So all that is provided over here. Then we have another parameter besides sample, that is basically the detail, right? So here you can see now it is providing us more details about our server where we are working upon, right? So similar kind of, so that now it is also providing information about the data locality, number of stores, right? So for every, you can see the complete data that we have in the your Hadoop, sorry, Hbase storage. It is providing us further details that we may require when we will be working on the big project. So you need to understand this. So for the time being, you understand that we can get more details. If I want to know the details about the total static bloom size memory, then mem store information, number of store files, the current compaction size. So all this information we can get by using this command status detailed or status simple. Then we move on to the version. So we know it is simply giving us all this information. That is, this is the version of the Cloudera Hadoop file system. So your CDHF5 13.0, this is the version of this particular system. Then we move on to the table help, right? So when we move on to the table help, basically it'll tell you what are the commands which can be used with the table, right? So here you see table help. So help for table reference commands, you can either create a table via the create and then manipulate the table via commands like put get. So here you can see let us say you don't know how to create the table. So it is helping you out. It is providing you the example how to create the tables, or how to put the data inside the tables, or how to retrieve the data from the tables. So putting the data insertion, for the insertion we use put, and for the, you can say, for the retrieval, for the selection of data that we want to see, we use the get command. So then, for instance, we can create a table. You can get a create table and keep around a reference to its via. So that means, let us say, while creating the table, you can also create a reference to that, so that later on you use that reference for the some other task. Like here, when we are creating the table, its reference is stored is in the variable t. T is equal to create t. So we are creating a table t, and then CF is basically the column family. So this is how we will be getting into the details. So when we are creating a table, we first specify the table name, and then we specify the column family name. And after that, when we will be inserting the data using the put command, we will be specifying the name of the column and the value that we want to store. But while creating the table, we are specifying only the column family names. You will have to go back and brush up your concepts, because your Hbase, which is a column family database. So in the column families, in each column family we may have multiple columns, and one table may have multiple column families also. So one way is to create a reference for the table is this. Another way is if you have already created the table and you just want to reference it, so you can write it T is equal to get table T. Now you can do things like put. So T dot put R column family, column name, and this is the value. So similarly, it will put a row R with column family CF, qualifier Q, and the value V into the table T. So now to read the data, we can use t dot scan or simply you write scan table name, right? So and every table name or the attribute name that we are going to write, we are going to write in the single quotes as it is being shown over here. So similarly, for more information how to use it, you can also type t dot help scan. So that means if you want to use to know the further details that how to use the scan, so you can also use this keyword that is t dot help scan. So this will help us. This will provide you more help, more details how to use the scan command over here. Then you can also give the general admin actions on the table like t dot enable, t dot flash. So t dot enable is used basically to enable a table, right? Sometimes let us say, so we have two keywords, one is enable, another is disable. So enable is basically you can say that we want to activate that particular table if you want to perform some kind of selection or the insertion, any kind of such operations. And if you want to, if you disable, if your table is disabled, you can, let us say, for the safety purpose also, you can use that. You just don't want anybody to delete or drop that particular table, so you just disable it. If and if you want to delete that particular table, you cannot do that without disabling it. So disabling a table is a prerequisite for either dropping a table or for deleting a table. So similarly, if we want to perform the other actions on a particular table, so the table must be enabled in order to do so. So then, who am I? The information of the current user that it is going to give. Who am I? So who am I? This is Cloudera. Author is simple, and then groups are Cloudera and default. So these are the basic groups which are there. Or there, if furthermore, you can say the clusters are being created, it will be showing like here in the this particular file. You can see it is showing various groups: HB user, Adam, CD-ROM, sudo, DIP, plug dev, LP admin. So number of groups are there which are being shown over here. Then there is another attribute that is called as time to live. See in all the distributed or HBase is a cloud database or distributed database. Therefore, all the information in these distributed databases, you can say a versioning system is retained over there. So whatever changes you can say, if you make a change, let us say you inserted a particular row in a particular table, so that particular information will be stored along with a version name or there is a timestamp. So when if you make a change in that particular table, so the previous it the changes are not overwritten on the previous data, but it is retained as another version of that particular. So that means at time X, you can say, let us say at 9 o'clock, the value was X, and at 9:15 value is Y, at 9:30 the value is Z. So this is how the versions are being maintained. So along with that, let us say you have if like if you see these days, like if you there is Diwali or there is Holi or you can say there is Raksha Bandhan, and there we always get you can say different types of offers, and these offers are time bound. So you can say, let us say there is some discount which is there only for a particular period of time from X, yeah, from from X date to Y date. So in that case, along with that, we can declare this discount attributes. We can specify the time to live attribute. So time to live attribute is there. So that means if when you have specified a particular date that from let us say 5th October to 8th of October. So after that, after the 8th October, this particular attribute will be deleted by itself. So that's why we are calling it as a time to live attribute. So there are large number of attributes which are required at different for different you can say for different purposes in the large applications like social media applications, like in the your e-commerce portals where we get large amount of offers for a particular period of time. So all these attributes may be specified to the time to live. So whenever that time is over, nobody is in programmer is not required to make any changes, but that particular attribute, that discount will be eliminated by itself. And your cells with you can say the attributes, your TTL attributes, they are expressed in units of milliseconds instead of seconds. And you can say, and another thing is, so your TTL, it may be that you can specify a single attribute as a TTL, or you can also specify, you can say, a complete row as a TTL. A complete row may be the case. Let us say you have hired some experts for a particular project, and they will be working on this project for 1 year or 6 months. After that, they are no more your employees. So you want to delete that record after that. So that means, and for the time being, for a particular period, we need to have the complete details of that particular employee. So in that particular period, let us say from 1st January 2020 to 1st January 2021, we need that particular record. And within that particular record, let us say that particular employee is also given certain incentive. So for a particular period of time, for let us say he works for some extra hours. So in that case, let us say we can have two TTL. One is for the cell and another is for the row. So a cells TTL, we have to remember, a cells TTL cannot extend the effective lifetime of the cell beyond a column family level TTL setting. So we have to understand, if there is a TTL for the column family, that will be dominating over the TTL for the particular cell. So this is how your TTL time to live attribute is being specified, and it is being used in your Hbase. Now we have other commands which we call them as the table management commands, like create table, list, describe, disable. I told you disable and enable. Let us practice these commands one by one. So now let's say we create a table using the create command. So create, let's say I'll create uh, uh, GIIT SHI. I'll have to remember the name. This is the name of the table. Then I'm specifying the name of the column family, which is, let us say, I'll create SHI. Actually, Shikha is the name of the column family. You can write any name over here. And then we put the table, right? So we have created one table with the name GIITSHI. Now, you can say this is your GIITSHI is the name of the table, and your SHIKHA, that is Shikha, this is the name of the column family. So we can, in one table, we can create any number of column families, and within the column families, we will be creating the columns, and then along with that, we will be adding the families. Since we can have multiple column families within the table, so while inserting the data using the put command, you have to specify the name of the column family into which you want to enter the data. So now let's see if you want to see the tables, whether it has been created or not, you use the command list, and it will show you the list of tables which are available. So edu, emp2, employee, git, emp, git, shi. So this is the table that I have just created, and it is being shown over here. So now let us move ahead with the further comments. Now let us see how, if we want to see the details of the table. So it will give us all the information about this particular table. So let us see, describe GIATSHI. So I want to know the description. So what are the column families? See over here. So the column family description it is going to provide. So the column family name is Shikha, data block encoding is none, Bloom filter is row. So that means our data is being stored row wise over here internally. Their application scope we haven't specified, version is one, right? So it will allow one version of this, and we can create. So we can see, we can also extend the number of versions we want to create for this particular copy. So it will allow the multiple versions of that. Then the compression. technique we have not specified. So minimum versions is 0, time to live forever. So here you can see TTL is basically time to live. So it is forever. If we will specify some time in the milliseconds, so it will survive only for that particular duration. Keep deleted cells false. We don't want to so here you have an option that whether you want to keep the deleted cells and you want to delete it later, you specify true over there, it will retain that all those cells. So block size is 6 by default. This is the block size. If you remember, we had talked about block size while discussing about the architecture. Then in memory, it is false. Then block cache, it is true. So it is giving the description about the GIT, SHI table, and it is giving the information about the table name with column families, associated filters, versions, and all the details that we have seen. So now if you want to disable a table, you simply write disable and then you write GITSHI. So we are this way we have disabled the table, right? So now the table is being disabled. So now if you want to, I just told you that this will be disabling the table, and if the table needs to, and we have to do this, but this is a prerequisite. If you want to delete a table or drop, you have to disable it first. Otherwise, it will not be deleted. Then you have disable all. So if you have multiple tables and you want to disable all the tables together, so you can use a regular expression over there. So let us say the names of the tables start with EMPs. Let us say E. So you want to disable all the tables which start with E. So you can use this particular expression. Oh, there is no matching. There is regular expression. Not name. Okay. Acha. Wait. It is not taking it up. Okay, let's move ahead. You can try it out. One minute. So then we have because we have to work with this table, we will have to enable it. Uh, just enable, right? So we have enabled this particular table, right? Then we have show filters, which help us in knowing what are the filters available, which are supported by this version of Hbase. So we are using this command in order to understand the various filters which are supported. Like you have column prefix filter, timestamp, page filter, multiple column prefix filter, family filter, column pagination filter, and this is going to be your you can say because all these filters are supported over here, so I'm writing it. So you're going to not paste it. So what you have to do is you have to practice all these filters, and you after this is your home assignment. So you practice all these filters, and then you have to write the commands and the output, show the output on the screen, and copy all the outputs on the screen of your and take those outputs of the screens and paste them in the Word file and then upload it. I'll be creating an assignment. You upload it over there. Okay. So next we have drop. I'm not going to drop the, okay, let me drop one table. Drop uh, EMP. Let me see the list of tables that I have already. List. Okay. Base. shell. I press some key and switch over to the Cloudera. So I'm going back to the Hbase shell first, and then I'll be typing list. So here you can see I have EMP2, employee, all that. So let's say drop EMP2. Local variable method EMP2. Oh, sorry. We have to use the table name and codes. See, now I am trying to drop the table, but it is showing me the error table EMP2 is enabled. Disable it first. This is what I was trying to tell you every time that whenever we have to delete or drop any table, we first have to disable it. Only then it will be available for dropping or deleting. Right. So now the drop needs and here it is also showing how we can disable the table. So what I'm going to do first, I'm going to disable. No, drop. No. As per this, we have successfully dropped the table. Let us see the list. The EMP2 table is not available now. That means we have successfully dropped that particular table. So similarly, similar to the drops, we have drop all. You can practice that. You can give a specific regular expression for that and see how to drop all the tables. But again, you have to ensure that before applying this command, all the you have to disable the tables that you want to delete. Now, let us check the status. So if you want to check the status of a particular table, is it enabled or disabled? You can check it using it. It's enabled underscore press. Let's say EMPLOY, any of the tables, let us see. Wait, okay. Yeah. So sometimes it stops working in between. So we have to restart the at the shell. So you may also face a similar kind of problem, but don't worry. You just switch over to the cloud area and again start that. What I was trying is underscore this. Okay, this one is enabled. Is enabled. Table name false, right? So that means this is disabled, right? So what we can do, enable, and then let us say again we do this. Now it is giving true, right? So since the table was disabled, it was showing false. So we can see the status of the table before we want to delete it or drop it. And after that, again, what we can say, I enabled it using the enable command of the command, using the enable command in order to create the employee table. And then again, I check the status and now it is showing me true, right? Then let us create few tables and then we will use the this alter commands tomorrow. So before that, let us okay, 1 minute. Okay, let us start. So create, let us say Let us see, we created one table, what was it? GIT. And what was the name of the, uh, we created one table, no? GIT, SHI, and what was the name of the column family name there? Anybody tell me? Can anybody tell me?
When you calculate Shikha,
Okay, fine, 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 fine. This, okay, now I need to do. So let us uh, create, okay, put GIT, SHI, right? And then comma, decision create Shikha, right? Right. So it's going to family name itself. And then, yeah, it was a mistake. And student also. Okay, let's see, describe. Student. So here it is that I had created student table, right? So student table is enabled. The column family descriptions in the column family, what in the column family, what I have the name that is age, right? Then all this information what we have, then course that was specified, and then we have another your age, course, and then the name, right? So the name of the course and the age that has been specified over here. So basically we have three rows over here, right? So let's scan what is there, the data that we have in the student table. Here you see. See, these are, this is the information that I had already stored. I'll be showing you how to put the data in that. So first let us see how to scan the data or how to get the data from the tables that we have created. So here you can see these are the 1, 2, 3, 4, 5, 5 rows that have been created. So basically there are two rows which is showing, so because there are two column families. So within each row represents one column family, right? So you can say so Rajesh, this is one column family, and Shikha, this is one column family. Within the Rajesh column family, what we have the age, we have specified, then we have specified the course name and the name, right? So the values is specified over here. So this is repeated over here showing, but this is one column, you can say one row with three columns. So the columns are age, the course it is pursuing, and the name or full name. Similarly, over here, we can see that your Shikha column family, what we have two columns we have specified. So one is age, another is a course it is pursuing. And here you can see, I told you all the data that we insert, it is being stored along with the timestamp. And this is the timestamp over here. So these timestamps help in identifying the versions, whether which is the latest version of the data that is being there. So the timestamps helps in maintaining the versioning into the cloud databases or the distributed databases. And here you can see, so here you can see within the one table, we have two column families, and each first column family has three columns, and the second column family has just two columns. So that's why we say this distributed databases, they are without schema. or they have the flexible schema, unlike your SQL databases, that is the RDBMS, where we have a rigid schema, fixed schema. We cannot change the schema over there. But here, this is, you can say, this is up to us, that is how many columns we want within one column family. So such kind of databases, basically, they are very useful when we are dealing with the social network kind applications where we have different kinds of data to store. So where we cannot have, you can say, the fixed schemas for the database, like we have the Facebook post, we have the tweets, within the Facebook, we have different kinds of data that is being stored. So for different kinds of, you can say, within one social media, social web application, within that we have multiple different applications for which we require different kinds of storage mechanisms. So your distributed databases help us in resolving the problems which were being faced by the Facebook, Yahoo, and the other giants for whether it was related to the search engine, whether it was related to the storage of data for the Facebook. So for storing the basically the unstructured data, we are sure Hbase storage. Hbase is very useful, right? So for today, I'll stop over here only.